For part B, we're asked the question, does f of minus x equal f of x? Let's use our calculator to explore. We'll create a table of values. First of all, go to Table Set, second window. And we'll change our independent variable from auto to ask. Next, go to Table, which is second graph. And we'll pick some pairs of minus x and x values. For example, -1 and 1. We see that the corresponding y values are both -1. How about -2 and 2? Both the y values are -0.25. How about -3 and 3? But both the y values are -0.1111. So our inclination is that f of minus x does equal f of x. Let's see if we can verify that symbolically. We first of all evaluate f of minus x. We substitute minus x for x in our original formula. We get k times 1 over minus x raised to the n power. But minus x to the n power is minus 1 to the n power times x to the n power. Now let's think about -1 to the n power. In part A, we determined that n is even. From our graph, it appeared that n is equal to 2. What if n was equal to 2? Well, -1 squared is -1 times -1, which is +1. Now even if n isn't 2, maybe it's 4, if we multiply -1 by itself 4 times, we're still going to get +1. -1 raised to an even power is always equal to +1. And 1 goes into 1 time, and so we can rewrite this expression as k times 1 over x to the n. But k times 1 over x to the n, that's exactly the same as the expression that we were given for f of x. So we can substitute f of x for k times 1 over x to the n. So the answer to the question in part D, does f of minus x equal f of x? The answer is yes. We could have answered the question in part D graphically as well. Notice that the graph is symmetrical about the y-axis. In other words, if we were to fold the graph along the y-axis, both sides of the function would coincide with one another. That shows us graphically that the function is even and that f of minus x is equal to f of x. For part E, we're asked, as x goes to positive infinity, f of x goes to blank. So what we want to do is to investigate the right hand side of the function and determine what happens to the y values as the x values increase without boundary. Well, as x increases without boundary, we see that the graph is approaching the x-axis, and the values of y along the x-axis are 0. So f of x is approaching 0. To reinforce this idea numerically, we could make a table of values. We want x to increase without boundaries, so let's start with x is equal to 10. And then we'll let x get larger and larger and larger. Let's let x be 100. And then 1,000. And then 10,000. We see that the corresponding y values are -0.1, -1 times 10 to the -4, -1 times 10 to the -6, -1 times 10 to the -8. These values are getting closer and closer to the number 0, And so as x goes to infinity, f of x goes to 0. What happens as x goes to minus infinity? Well, we need to investigate the left-end behavior of the function. As x goes to minus infinity, we see that the points on the graph are approaching the x-axis again. The values of y along the x-axis are 0, and so f of x is approaching 0.